Hello everyone. Today I am alone. My name is Alexander Zelenin, and I think I can pick some hard problem with some small success rate. So I will go with determining DNA health. I already had read the task itself, but right before starting of the stream, so just to save a bit of time. So you can set on pause and read by yourself. And I will try to explain by my own what the task we have here. So we have some gens. We have array of them, and we have another array that represent health of these gens. And we have a string of this gens combination. And we have two numbers. So the first number represents the first index when we when we start to determine that this gen means something to us, and will mean the end gen that means something to us, and D will be a string that will represent the gens itself. We will need to count health of this gens from string D. It will be calculated by making sum of health of gens that represented in this string D, but only the gens from the array with the indexes between these two, including them. And in the end, we will need to write the unhealthiest DNA and with maximum health. This sounds complicated with like a lot of incoming variables and so on, but it doesn't look so hard, or maybe I'm wrong and I missed something. So our constraints. I always forgot what does these letters mean. Because what if there will be like first, last, all of them will be called like this, will be much easier as for me. So n is health, n is values, and n is health, and s number of strands. Okay, the number of gens and number of strands will be less than 100,000. Every element, so health of every element will be up to 10,000 millions. So it's possibly that we will need to use some string math or like big int or something like that, because some of the big numbers probably will not be handled in memory by with just default integers. So and the chains itself, we have by some reason called start and last. I think it's start and end. Okay, so the start is minimum 0 and is lower or equal than the end, and it guarantees lower than the number of the gens itself, because we're starting from 0. So and the sum of the length of all gens of the nth trait is maximum 2 millions, from 1 to 2 million. So we don't need a big int. Okay, this condition means that we don't need big int. We will be under just integer, so that's good. And all gens consist only of lowercase English of alphabetical letters from A to Z. So here is an example. Also, I presume that in this example there is a typo. I will explain a bit later, because otherwise, if it's not a typo, that means that I don't understand the problem, what is possible. So we have string A, B, C, A, D, B, and health is 1, 2, 3, 4, 5, 6. Representing like each of them. So for AA it will be 4. So one of the things here, one of the like problem, that it can start with the same letter. So we can have A and AA, and this is like different gens. So we have 3 strings to test. We have first one from 1 to 5, C, A, B. I presume that there should be D or something like that. I will explain it later instead of B. X, Y, Z, and then, okay, I will not read this, it doesn't matter. And our answer should be like 2 numbers, the lowest and the highest one. So when we go with the first one, with this one, we have this initial information about our gens. We will go from first to fifth one, and we will go here like we will use only from first to, not from first, it's second, but for indexes it will be first and fifth one. We use only these ones to determine what we have here. So we have first letter C, we have letter C here, so it's 3. The next one is 2 letters A, so it's 4. I presume that we should choose the longest gen. I'm not sure about that, but I presume that it works like this. So then we choose like next AA. After this, only one A left, and by some reason it was missed. I'm not sure why, but fine, because the middle A was reused at one time. I think with another example we will understand it better. So, and then we have B. So for B we have 2, and by some reason this B used again. I presume this is mistake, because the number here is 6, and for 6 we have B 2 times. Okay, then this means that I doesn't understand from the start. Maybe I understand it not properly, or maybe we need to just make a sum of these gens, like we get 2 from position 1 and 5 from position 5. So okay, if for our number we have letter 2 times, that means that we can use it 2 times. Okay, that means that what I think initially will not work, so I will need to find out some other solution. Fine, That's more interesting. So, like for the next one, we have diapason, or we have range from 0 to 4, and there is no such letter, so sum will be 0. And the last one, we have range from 2 to 4, and we have C, A, and D. First of all, we have C, which leads to 3. We have D, which leads to 5, and we have C, which leads to 3 again. So the total health will be 11. So on healthiest one will be 0, and healthiest one will be 19. So we will print 0 and 19 in the end. Initially, I have an idea to use something like a tree to store the name of gens itself, to find them efficiently, like to take a look at next letter, to go down in the tree until I will go to an end. But here is the problem with the indexes of the array. Maybe I still can use this approach, and like on the leaf, I will store some index and health value. So it might work. Also, I presume that it's possible that for some gens the value is always greater than 0, right? No, health it's possible to be 0. So we will ignore from the start the gens with the 0 health, since they will doesn't mean anything to us. So let's see what we have here. Looks like we doesn't have any function at all, like prepared. Maybe I need to reset. No, okay, so we doesn't have any function at all. Let's create one. How it will be called? Let's call it determine then a. So, and we will have next arguments. First, second, third line. So we have here like this. We go through everything, or we can do it here maybe. No, I don't want to make it here, so let me just to reduce code a bit. So we have n, we have gens, we have health, we have s that represent count of these chains, not the chains, how it called, I forgot already the word. Okay, doesn't matter. We have the first, last, and D. Let's create an array. Let's call it chains. I will just go through this array. I didn't consider this as a complexity or something like this, or it's just for easier for readability. So We will push these values here, so first, last, and D, like this. And we will call our method with our arguments. So we have gens, we have health, and we have chains. Other things doesn't matter to us, and we will need to print two values. So let's start with like min, max. It will be not 0. I will change it now. For minimum it will be infinity, and maximum it will be minus infinity. Okay. And in the end we will print I hope console log will work for printing. We'll print both of these values. The first one should be the lowest one, yes, min, and the second one should be maximum one. Okay, so our logic will be here. So first of all, I want to describe what structure I want to have here. So if we have, for example, let me copy this example here and try to clarify how the structure will looks here. So we have a letter itself from the start, then we'll have something like result, or result is possible to be here. So I mean it's letters, and it's possible to have again called result. So I will use some additional symbol, or do some additional symbol, just to be sure that we will not have problems with gen names. So in this result I will have something like a pair. So let's have an array, and I think it will be like array of arrays, like this. And first we store the index number, and then we store health, so for letter A. After this we will have B, which lead to something like this. Again, it will be not too different, so 1, 2. Something same for C, but more interesting will be for AA. For AA we'll have nested A here, and we will store, I have no idea why it's moved. We'll have nested A, and we will have another result with the value of the index is 3 and the value is 4. Okay, so when we will go through our gen, we will go through this chain, through this dictionary. We will find our gen, then we will go through every value in this range, and we'll see if it's between the first and last one, and if it's between, then we will add this amount to current gen, and after we make the sum, we will compare the gen with minimum and maximum. So it sounds good to me. Let me put it before and make it comment. Okay. So, okay, no, I don't want to do it like this. First of all, we need to generate this structure, and also we need to receive variables itself. So we will go through gens. This is array, right? Yes. This is array of letters. So let's create our structure, initial one. Then we will go through gens. Okay, so we have some gen that consist of letters. We will go through these letters to put it to the end of the structure. So from 0 while I is less than gen length, and we'll have letter here, which will be equal to gen I. So we will go inside of our structure, like structure letter. It will be first of all we need to create itself if it's not exist, so we'll create an object inside. It also will not put a result on every level. So for example, if we will have only AA, there will be no this result, and like we will live only with this one. Okay, so and I also need to create a variable here which will represent the current position. So current position will show the current node when we go inside. So current will be equal to structure letter. Then we will need to work like with the current one. So like if we have the first letter A, then current will be equal to this one. So we need to go inside of the current. And if current letter is let me write just with if it not exists, then current letter will be like this. Okay, and initially we will assign our structure to current. So initially the current will be referring to the root of the tree. structure. Then when we got the letter A, we checking if we have letter A here, and if we doesn't have, we create an object and make a current to this object. After we go through all of them, the current will have like the leaf. So we will add to this leaf our result. So current result will be equal current result, or array will be equal current result or array. The micro optimization, what will be possible here is when we will go through these arrays, we will able to stop when our index is higher than boundary, because all of them will be in order since we go from 0 to the last one. But it's like micro optimization. Also, maybe it's possible to use initially something like binary search to find like the first one. If we will have like a lot of results for some of the letters, like 100,000, we will able to find with binary search like the first one, then go from the first one to the required one, and it will be efficient enough. It will be efficient enough. Okay. So we creating a result, and we need push to this result current value. So we will push I think we need index also, gen index. It will be the same index in health. So we will put two values. First of them will be gen index, and second one will be health of this gen. But as I told previously, we can add some additional condition in the start, like if it equals to 0, then we will not count this gen at all, because it doesn't matter, it will not give anything to us. So I presume that we generate our structure, and from this point of view everything looks fine to me. So now we will go through chains. Okay. It's not chains, I don't like this name. What was the proper one? Strands. Let's rename it from chains to strands. So we go through strands, and we will here have like one variable that is array with through 3 variables inside. Let's call this one as combination. Since I didn't like the one letter names, it's very hard to, for indexes like this is fine, but for some names, or when there is a lot of names with one letter, it's very hard to understand what is happening. So we will go through our things. First and last we will use later on, and first what we need to do is to go through our combination. We will make a cycle from the first letter to last one, while I is length of the combination. Will increase I by 1, and we will create another method that we will call like find gen. That will receive, first of all, it will receive structure, and second, it will receive the string itself and current position. So combination and start position. I will try to explain it a bit to be a bit clearer. So we have a start position, like with this example, for example, we will start with A, and we will need go for like next letter, next letter, next letter, and so on until we got some result. Not until we got some result, but until we doesn't have anything inside by this letter. So there will be some while cycle. So we will go through. So first of all, the first letter will be like this. So let's create it like this, and we will increase current position. Let's create another variable, just position, that initially will be equal to start position. We will increase this one later on. So we have combination, we have current letter, and we will go through, like it will be like operation like this, but backwards. So not the backwards, but we will go through structure and and try to found everything inside. So let me just copy this one. It may be useful. So we will go from start position up to combination length, so up to end of the combination itself. We have current letter, so I think we don't need the position itself. We have current letter. If it doesn't exist, then we just break. Okay, otherwise we go inside, and we repeat this until some typo need to be more careful about copy pasting some parts of code. So, and we will go inside until it's possible. So if it's possible to go inside, then we go inside, otherwise we stop. So after this, we can check if current have a result. So yes, I presume we don't need to check that current itself exists because we check it here, and like on every yep. So we checking that some result is exist. Then we can go through our results. So we'll have another cycle here. Or maybe we can do this here. Let's call it find Strand Health. And we will call it here. So it will be structure combination I, like this. Just some temporary name, just to remember that something is here. So we go through the results, and we will need to see that a result. Let me create two more variables. So result I. We will have two variables. First of them is index and second is health. So it's gen index and gen health. So we have two of them. We can we should create another variable, health, and we will return this health. So initially it's 0, and we will increase this with what we have here if the index is between them. I didn't pass the limitation here, yes, first and last. So maybe let's go here, and we will return the value here. So instead of health we will count also here. So gen health is 0 initially, and we will just return the current one, and that's all. So it will be not gen health, it will be just find gen. So we had find the gen itself. Its initial health is 0. So if let's rename it from current but to gen. If gen has results, we have gen index. We have okay, this is not no, it's gen health, right? I'm just thinking how better to count this, how better to name it. I don't want to name it just health. Okay, I think this one will be not gen health, but like current health, because we have a couple of values for the same gen with different indexes. Like, let it be current health for now. Okay, so we will test that our index is between our boundaries, and our boundaries is defined here, first and last. So our gen index less or equal to first, and gen index less or equal to last. If so also let's mention here that it's possible to find start position with binary search. But for now we will go with this solution because already we spent a lot of time for solving this task. So we have gen index, we have our condition, we are like happy with this condition, and if we meet this condition, then we can add to gen health or current health. Okay, so looks like we had the count health of our current gen, like sum of this sum of all possible combinations. After this, we need to have something like Strand Health that will be equal to 0. So after we count gen health, we will increase Strand Health to gen health value. And after this cycle, we can test our Strand Health again against min and max. So if Strand Health greater than max, then max equal to gen health. If gen health is like less than min, then min equal. I use two conditions instead of else if, because for the first value, at least for first value, it will be like greater and lower like the same time. Okay, what else we need to do? Let's see. We create a structure. We go through every strand. We count strand health by going through our string. We go through starting with every letter. We try to find the gen itself. If this gen has a result, then we go through this result and sum all possible things that applied to the gen itself. After this, we change max and min values, and looks like it is. Maybe I had missed something, or gen health not defined. Okay, 93. Because I need to use Strand Health, sorry. Okay, well, so we are working with the Strand Health, not with the gen. Yay, at least test example work fine. So let's submit our code and hopefully it will work now. So some of cases fails, but wow, we have a lot of test cases here. So some of them are successful. Just few of them are successful originally. So I think we need to unlock some of tests and see what we have here. So we have let's see what we have here. Wow, this looks as super long test. So we will need to test against this input by our owns and see what okay, it's stuck. I will try to reduce the sound a bit. The browser won't respond for this amount of data. But what is important for us in this case that we got the wrong answer and not like it's not a timeout or something like this. So something was counted wrong by some reason. It's just stuck. Okay, browser stuck, I can't do anything. I cannot think when baby crying on the background. Okay, I will need to refresh. Okay, the page will be not refreshed. It doesn't work at all. So, okay, browser is crashed, I hope. Okay, let's go back. Everything is fine now. I think it will be reasonable to run everything on my own machine instead of running it here, because it will probably doesn't work, but I will try one more time to run code here and see what will be. Next time I will prepare environment to run on my machine. Okay, it's uploading, at least something happens. The custom input size should not exceed 50 kilobytes. Okay, I need to prepare next time my machine to run the code locally, because right now like I cannot run it locally. I'm not sure what is wrong with the output itself. So let's remove this, try one more time and see what was the problem. So we have input 10. The test number 10. So we have only expected out. My assumption that no, it's not the beyond integer limit, so it should be fine. So, but we have like about 300 millions, and initially, by condition, we have the maximum length of like 2 millions. And no, I doesn't think that problem is with the counting, because it's still under the integer value it should be. Or I can maybe run this code. No, in browser it will not work well, so like this, because it should be modified. Okay, I think we will stop for today. I will prepare environment to run and test it properly, and we will find the proper solution tomorrow. At least we got some points. Thank you for watching, and have a nice day.